Hi, you all just finished a U-try where you got to decide if a relation defines y as a function of x, and you got to give the domain. And I gave you the equation y equals 6 over x plus 2. So let's decide first, is it a function or not? So if it's a function, what we want to know is for every x value that you input, how many y values are you going to get? Are you just going to get one, or could you possibly get more than one? So for every x value that I input, thankfully all of the operations are on the same side with the x, which is perfect. Every x value that you put in, you're going to take that x value and you're going to add 2 first. Well, adding 2 still gives you just one answer, just one number. And then once you get that, you'll do 6 divided by that answer, which again would just give you one number. And if it helps to do some concrete examples, maybe like let's say that x is 1. Well, then you would do 1 plus 2, which would be 3. You would do 6 divided by the 3 that you just got and get 2. So you'd have the 0.12. All right, well, let's try one more just to make sure that we're good. What about if x is 0? Because zeros can be fun, right? Well, then you would do 0 plus 2, which would be 2. And then you do 6 divided by 2, which would be 3. So you'd have the 0.03. And you can keep doing this as many times as you need to feel comfortable, but at the end of the day, every single x value that we're putting in, we're just getting one y value from it. And so that means that it's a function. All right, what about the domain for this one? So the domain is all of the x values that get used in our function. And so the domain, the only really restriction we have, if you guys remember rational expressions, is that you can't divide by 0, right? Because dividing by 0 gives you an undefined value. So the only kind of restriction that we have is that denominator, the x plus 2, it can't equal 0 because we can't divide by 0 and get something undefined. So for my x, what that means is that x can't be negative 2. I'm just getting that by subtracting 2 from both sides and solving for my x. So x can't be negative 2 because if x is negative 2, then negative 2 plus 2 is 0, and then we're dividing by 0, and it gives us this undefined thing. So everything else should be fine. Like, that's the only restriction you're going to have. Because if I put a negative number in there, that's fine. I mean, we just get a negative y value eventually. You know, if we have like negative 4 or something like that, negative 4 plus 2 would give you negative 2. 6 divided by negative 2 would be negative 3. We'd get a negative y value, and that's perfectly fine. So negatives seem okay. We've done some positive. They seem okay. It's just this one value that x can't be. So now that we have that, okay, it's everything except negative 2. That's kind of where we're at right now. How do I write that in interval notation? All right, well, sometimes I know I'm a very visual person. It helps to kind of graph it out. What's happening is you have this everything, but not negative 2. And so interval notation wise, what we're going to do is we're going to have 2 chunks. We're going to have one piece to the left of negative 2. We're going to have another piece to the right of negative 2. And we're just not going to include the negative 2. So in interval notation, what this looks like is how far left do we start? We just keep going forever. So that would be negative infinity. And then we're going to stop when we get to negative 2. I'm going to use parentheses for both. You have to use parentheses for negative infinity because it's an infinity. But we're going to use the parenthesis at negative 2 because it's not equal to negative 2. We're excluding it. We don't want it in our domain. All right, the second little part is going to start at negative 2. And again, I'm going to use a parenthesis because we're not including it. Comma, how far right do we go? We keep going forever. So that's positive infinity. And then these 2 pieces, we're going to join them together with a union symbol. So that's what it looks like when you just hop over one value. This goes from negative infinity to negative 2, but not including negative 2. And then not including negative 2, and then it keeps on going. So it's everything up to negative 2 and everything to the right of negative 2, but just not including it. And that's what your domain looks like for this function.